Okay, so hi students. Today we will be looking at advanced fractions. So first things first, we will be looking at multiplication. So for fractions, when we are doing the multiplication operation, it's different from when we were for wetlanders. It's different from when we were doing addition and subtraction. So if we recall from when we were doing addition and subtraction, in order to add two fractions or subtract two fractions, our aim was always to ensure we had the base being the same. Was always to ensure we had the base being the same. So for instance, just a little recap. For instance, in order to add, we would first need to have like 2/3 plus 5/3 in order to add those together. That would be the most efficient way to do it. Not the only way to add them, but the most efficient way to do it is to ensure you get the base to be the same, and then you go on to simplify. But for multiplication, this is not required. For multiplication, we simply multiply the numerators. So we multiply the numerators in order to get the new numerator, and then we multiply the denominators in order to get the new denominator. So in this example, we have 4 divided by 5 multiplied by 2/3, so 4/5 multiplied by 2/3, and that gives us 8/5 because we have 4/5 multiplied by 2/3. And so by multiplying the numerators, we get 8, and multiplying the denominators, we're able to get 15. And as I said, notice that we did not need to go about changing the denominators to be the same as was the case with addition and subtraction. We did not need to go about getting the denominators to be the same base or anything. Likewise with the example number 2, we have 20 divided by 45, and we're multiplying that by 15 divided by 40. This case is a bit different. So this example is a bit different because whereas for the first one, we simply multiply the numerator and multiply the denominator and kept it as is. For the second example, if we do that, the 20 multiplied by 15, it would be very complex. It would be a complex number. So in some cases with fractions, we're actually able to to to, to simplify the fractions before we completely evaluate them. It's a very useful technique in multiplication. So we look at the numerators and the denominators, and we always seek to see and be simplified further. Simplified further simply means if we're able to find a common factor between a numerator and a denominator. So it can be this one and this one, or it can be the 20 and the 40, or it can be a 15 and a 45. So the aim is to find a common factor between a numerator, any numerator, and a denominator. So one numerator and one denominator, which is any one, and then you keep recording what the new value is after simplifying it, after dividing through by that common factor that you have found out. So one example, so the first step, or common factor between 20 and 40 is 20. And sometimes we can easily figure out what is the highest common factor, but sometimes we're only able to pick out what is probably a smaller factor, like we could have said 2, and 2 would have given 2 into 20 would have given us 10, and 2 into 40 would have given us 20. Then we would have realized that that can be simplified further. And simplified further, we mean that, so we would have said 2 into 20, and realize that 2 would go into 20 and 40. So we would have said 2 into 20 gives us 10, because 2 times 10 is 20. And we know that 2 into 40, right? We would have realized first, as I said, we would have realized 2 into 20 goes 10, and then we would have realized that 2 into 40 goes 20. Okay? But then that can still be simplified because we realize that there's still a common factor between these, aka a number that can be divided into both those numbers without leaving a remainder, and that's 10. We could have used 2 again. We could have used 2 again. It's 2 into 10. It's 5, right? 2 into 20 is 10. Then we could have used 5. 5 into goes 1, or 5 into 10 goes 2. We would have gotten a half. But if we find a small common factor, realize that the process is longer. We'd have to keep doing that until we simplify it further, right? In some cases, they'll ask you to simplify the fraction completely. And so you could do this long step by starting off with the smallest fraction, or the factor that you easily recognize. Or in some cases, you'll be able to easily pick up the highest, and that's usually most effective, most efficient. It's easy to pick up what the highest common factor is. So with that same one, 20 and 40, we can realize that the highest common factor would be 20. 20 is the highest number that can go into 20 and 40. And so we set 20 into 20, okay? 20 into 40 goes 2 times, because we can get 2 groups of 20 in 40. 2 times 20, great. And so we've dealt with that, and if we realize we still end up with the 1 over 2, whether we do it this short way or if we do it the long way. And so we move along to another numerator and another denominator. The quick way is that 15 can go into both of these. So 15 into 15 goes 1, and 15 into 45 goes 3 times. Then we go back to our fundamental principle. After we've simplified it, we go back to our fundamental principle, which is simply multiply the numerator throughout and multiply the denominator, which will give us 1 upon 6. Okay, great. Which will give us 1 upon 6. Let's just erase workings. Okay, and that was pretty much it for multiplication. And what's interesting about division is that some mathematicians would say that there really isn't such a thing as division, working out division. It's just a little joke, as working out division in fractions, because you really just reciprocate, which means flip or exchange the numerator with the denominator of the last fraction and multiply. And that is how we do division for fractions. And so we keep 3 over 7. So we have 3 over 7 divided by 15 over 21. We keep the 3 over 7, and then we multiply by 21 over 15 instead. So we simply reciprocated, and that word reciprocated, a reciprocal, means whatever the numerator was has now been exchanged for So the reciprocal now means that we exchange the value of the numerator, the value of the denominator, and that is the reciprocal. That is our reciprocal. And so in this case, our reciprocal is 21 divided by 15. And so we continue with what we've learned about multiplication. We first see if we can simplify, and then we go about multiplying the numerator and multiply the denominator, keeping it as a fraction. And so we would have simplifying 3. Let's see, I said that for simplification, we simply look and compare a numerator and a denominator to see if there's a common factor. So we can look and see if 3 and 7, right? It can be any denominator that we compare. We look and we see, does 3 and 7 have anything in common? No. So 3 and 7 does not have anything in common. And so we can compare the 3 with the 15. And then we realize that 15 divided by 3, 5. 3 divided by 3 is 1. Then for these two, a common factor would be 7. 7 divided by 7 is 1. And of course, 21 divided by 7 is 3. And that is how we got 3/5. That is how we got 3/5. Great. We got 3/5 that way. And so when the next example is 8/22 divided by 4/11. And so we do the same procedures. We first find the reciprocal, right back the first fraction. Then we find the reciprocal of the second. 11/4. Then we proceed to see if we can simplify. We're able to see an 11 and a 22. And so 11 into 11 is 1. 11 into 22 is 2. Then we can either compare the 8 and the 2 or the 4 and the 8. So let's just do the 8 and the 4. So 4 is common to both 8 and 4. 4 into 8 is 2 times, and 4 into 4 1 time. And the both 2's cancel. And yes, this division is supposed to be changed to multiplication since we have switched it. So our answer would be 1. Great. So that was the end of division. And so now we are going to look at multiplication once more, but this time it will be multiplication with mixed, with multiplying mixed numbers. Multiplying mixed numbers. So where we have to multiply a mixed number, so a mixed number has a whole number and it has a fraction. It has both a whole number and a fraction. And this might be a bit harder to work to solve than if it was just 2 fractions or 2 whole numbers. And so when we have a mixed number, what we always aim to do is to change it to an improper fraction first. Change it to a way that we are more familiar with it. We are more familiar with it, which is this way. It is all in one. And so in order to do that, So we change this first fraction. In order to do that, we say it is the denominator, my bad, the denominator multiplied by the whole number, the denominator, so multiplication signs right here, denominator multiplied by the whole number plus what is in the numerator, right? And the whole purpose of that, essentially, is that for fractions, we want it to be of a form that it can be easily compared and simplified. We can evaluate our fraction. And so when we have 1 and 2/3, 1 and 2/3 is easier to work with if we're able to put all of this in just one fraction. And so the best way to look at it is to think of this 1 as a fraction. If 1 was supposed to be changed to a fraction that can be easily compared with the 2/3, that means it would have to be in terms of 3. Now, how can we get 1 to be something in terms of 3 in the numerator, in the denominator? Well, 3 upon 3 is 1. So this is basically 3 upon 3 to multiply and 2/3. Because how we read a mixed number is 1 and 2/3. So the and means multiplication. Then we realize that that gives us 5 upon 3. In other words, let's say if it was a 2, we want to get 2 in terms of 3. If 3 is the base, right? So in fractions, 3 is the base. And if we have the exact amount, completing that 3, this makes the whole, right? And if we have the exact amount, 3, that would make it 1. If we have double the denominator, which is 6 upon 3, we have 2 more than what we're taking it out of. So I have something out of 3, right? So my whole is 3 because it has 3 portions. And if I have something, if I have 2 out of that 3, just a fraction of it, right? Let's say I have another one with 3. Now I have 3 upon 3, and now I have 3 upon 3. Now both of these would really be 6 upon 3, gives us 2. So that's the aim of this whole improper fraction thing. But a simple way to work it out is we just say that the denominator 3 multiplied by this number 1, right? Multiplied by the number 1, because in actuality what we are doing is that we're trying to convert it into a form of 3, you know. We're trying to convert it into this form by multiplying it by 3. Multiplying it by 3, it's like we have this 1/3. I multiply this by 3. What do I get? I get whatever my numerator was right here, which is 1. So I'm multiplying this by 3, and then I add my 2. So that would give me 3 times 3 plus 2, which is 5 upon 3. The same with this second one, which is 2 and a quarter, which gives me 4 times 2, 8, and 1, 9, 9 upon 4. We multiply across. Of course, we're able to see if there is any common factor. Realize that there's a 3, 3 into 3. 1 time 3 into 9, those 3 times. So we multiply across, which is 15 divided by 4, and this is simplified. But if we want to get it back into the form of a mixed number, because the whole is 4, we are going to see how many 4s can we get out of 15, and we're able to get 3 4s, because 3 4s is 12, and the remainder goes to the top. The remainder becomes the numerator, and the numerator is 3. Okay, right. So then this now is another example of multiplying mixed numbers, where we first try to convert it to an improper fraction by saying the denominator multiplied by the whole number 10 plus the numerator gives us the new numerator, right, which is 11, and we keep the denominator. Likewise with this one, 2 times 2, 4 plus 1, 5 divided by 2. See if there's anything we can simplify. No, there's nothing. And so we multiply straight across. So 11 times 5 gives us 55, and 2 2s is 4. Now we are able to change it to a mixed number, back to a mixed number, by seeing how many times can 4 go into 55. So leaving a remainder, that will give us 13, and then the remainder is 3, and then we put back the 4. And this is yet another example that I'd love for us to try similar examples to these, just to ensure we get it, just to ensure we wrap our minds around the concept of working from mixed number, getting it into an improper fraction, because sometimes when we're working it out very quickly and get confused, trying to remember, should I add this, should I multiply this, or whatever. And then we practice. Practice makes perfect. And so we'd have the denominator be multiplied by the whole number, get 24. Then we add the numerator, which gives us 27 divided by 4. So I want us to pause and just grasp that. Just grasp that for a second. Right? So I hope we would realize by doing these mixed numbers is that when we have 6 3/4, we're really trying to put it all together in terms of 4, in terms of the denominator. We have it out of 4, and when I now multiply 6 by 4, I am saying, okay, if I have something out of 4, right? I have something out of 4. If you have something out of 4, let's see if we can write. So if you have something out of 4, and as we were looking before, 4 out of 4 completes it, right? So if you have 4 things and you pick up 4, that's 4 out of 4, that's completed it. But if you were given 4 assignments and you did all 4 of them, I hope you have done all assignments. And so you've completed a whole. But suppose there's 4 additional, so that's 8 out of 4. That's double what the initial value was. And then if we now have 12 over 4, that's triple. Right? And we can continue so on and so forth until we have 6, right? So 6, how we're able to express 6. Wow, this is not, that's all. How we're able to express 6 basically then in this way, it would have to be 6 multiplied by 4, right? Gives us 24, right? And that is over 4, right? Times 4 would give us that 24, and then we keep it over the 4, right? Which basically means if we have 24 divided by 4, that gives us 6. I hope we can, wrap our minds. Eventually it will become clearer and clearer. And so we now know that 6, can write 6 as 24 over 4. And then now we already had 3 over 4. So we add that other fraction, and that is how we get 27 over the 4. Okay, great. And then we multiply by 2/3. See if we can simplify. Yes, we can. 3 into 27 goes 9. Goes 9. 3, 1. 2 into 2, 1. 2 into 4, 2. And so that gives us 9 divided. Okay, guys. So we have looked at multiplication and we have looked at division. And so we'll stop there for today. And I hope we are a tad bit more comfortable with fractions. Fractions is not something that is supposed to be dreaded. It's not something to be dreaded. If we practice it more, we'll realize that it gets fun. It becomes fun and more enjoyable to work with fractions. I mean, some people might say the normal numbers get boring sometimes, Just spruce it up with some fractions. And so I hope we have a great day. Yes, I really do hope you had a good time at this camp as it's wrapping up, and I am available to be in the session at the time due to other things. But I hope you have an amazing day and an even better rest of your summer. Bye guys. Tune in for the next video.